Uh, Thank you, Mr. Ramesh, for that wonderful presentation. Now I would like to call on stage Mr. Vinod Ninan, as he will be presenting on Industrial DataOps and Agentic AI and how they are helping industries scale manufacturing operations.
It's a great opportunity to stand before you today. Thank you, ARC team, for the opportunity. And I also want to thank Leena ma'am and Ramesh sir for already introducing about the various manufacturing as well as the AI cases. So need not be any introduction as such into that matter. Going forward, I think just to introduce the point which I wanted to just run through. We have been always talking about data as being the oil for any manufacturing industry. But my interaction with many of my customers is not that. My interaction when I talk to many of the customers, they are already flooded with a lot of data. But the point which they are not able to grasp or understand is how to make meaning out of this data which is already there. So that is where we would like to discuss today. And we will try to spend a few minutes on trying to understand why many of these AI pilots stall in many of these cases, why industrial DataOps is important and still relevant in the age of agentic AI, and how agentic AI can also scale manufacturing projects. So let me start with it. What is driving industrial AI adoption? That's one of the key points which we want to discuss today. One is, as we all know, we are talking about data explosion. And when we talk about data explosion, it's more about different types of data. It could be industrial data, it could be data which is coming from engineering system, business systems, and multiple other systems. Then we talk about the complexity involved in this. That comes basically because of the dynamic operations and the various new smart sensors which are already deployed in many of these systems. And of course, we are also, not only in the West, India is also facing a loss of a lot of skills over a period of time. So that is another reason why there is a huge drive for AI adoption. And as we heard from Ramesh sir just a couple of minutes before, we also have a challenge of huge cost and high unplanned downtime. And energy optimization is one key point which is also driving. And most of all, we are all driving into the autonomous area. So the question in front of us today is not about how we can run an AI pilot in this agentic AI space, but the question is how we can scale. That is the question in front of us. And when you talk about scaling of AI projects, it is not just talking about the scalability in terms of numbers. It is also talking about the productivity which is required. It is talking about the governance which is required because you are talking with multiple data. You're talking with agents. It is talking about the resilience which is required when you want to scale one project to hundreds and thousands of projects, as well as the autonomy which needs to be governed. So this is the key area. So the question is, in manufacturing, AI pilots are not the problem. It is about scaling across plants, assets, regions, and enterprise. So let's start one by one. So industrial data exploration. So there is huge explosion of data. And this could be because of the data which is coming from operational system, IT systems, it could be engineering system, GIS systems, and multiple other drawings and other systems which is there. It could be the historians, the traditional historian data which is coming. It could be the MES data, the ERP data, or other data as well. And because of which you have, what is the outcome of a lot of data? You have a lot of alarms and events which is there. You need to manage that. You have a lot of asset hierarchy which is getting created within the enterprise, and many of these asset hierarchies very disparate. It may be moving from one organization, one industry, and other organizations as well. And there is a huge list of maintenance history which you need to tackle. And many of these things in this age of AI, unfortunately, is in papers. It's in logs, which is there, which is moving from one shift to another. And there is analytical models which is also coming into picture. And we have a lot of procedures and workflows which needs to be managed as well. So that is one of the primary reasons why many of the AI pilots get stalled. And I would like to bring before you 3 points why many of the AI pilots stalls. The first is the fragmented content. The fragmented content and the context which is not there. So every time when a new AI project starts, you start and establish a new pipeline to it. You start establishing a connection to the systems. And over a period of time, it's unmanageable. And the second thing is when you want to have multiple systems connected to each other, you will have to establish different pipelines. And here you are creating siloed pipelines. And that's why I said it's not about data, but it is all about how to bring context to the data. And the third point in front of us is the low operational trust. And what happens when such systems are there? Even the operators, when you go and talk to the supervisors and try to put your pitch over there, they are not at all interested in your solution. That's the area where we are all challenging. So the question in front of us is, how do we address this engineering efforts? How do we address to generate a lot of insights with actions? As well as how can we replicate one AI project from 1 to 10 to 100 to 1,000? So I would like to say that even though in this age of AI, data is still very important. And the need over here is contextual intelligence. How do we get contextual intelligence? But contextual intelligence can be possible only when you have a proper data management solution, which is guided by the right governance tool and as well as the right pipelines which are there. So that is where we need to bring out or take out all the fragmented and siloed data sets which are there, bring all these things together and ensure that we are able to go into a bandwagon of scalability. So here we are talking about different OT systems, the IT systems, multiple documents. Because of RAG-based generative AI, we are talking about a lot of documents getting churned out into our repository. So you need to tackle those things because a lot of information is being there as well. And once you introduce a solution like Industrial DataOps, and in this case, we have a solution like the Genix Industrial DataOps, you will be able to unify the data. You will be able to trust the data because you know the origin of the data, who owns it, and how much scalability can be done, and what is the trust which you can be put into that particular data. And that makes us AI ready. Without this, no AI projects will not scale. You need to have a proper contextual intelligence in this, and that's the only way that we can scale. And this will determine how many pilots can be converted to real rollout projects. And that too at an AI level or an analytical level, or it can be just a simple dashboards which we have made 1 year before converting into applications. Agentic workflows where you are focusing on a particular MCP and trying to create agents which can do your work in a semi-autonomous way, as well as ensuring that we still have human oversight. And human oversight is still required to ensure that critical decisions which needs to be done, sometimes with an immature agentic solution in place. So that is the primary foundation for anything. Now, with only data, it cannot serve the purpose. So that is where we need to build the next building block on top of data. And that is where industrial AI comes into picture. Industrial AI has two parts. One is the physics-based models, which we call as the domain first principle models, and the other one is the data-driven AI. And this needs to work hand in hand. If you see many of the ABB systems which are out there, it has been running over the last 10, 15, 20 years on physics-based models. And that used to give the accuracy and that used to give the resilience for many of the outcome which was there. But with more smart IoT systems coming into picture, more generative AI data getting into picture, we need to go one step forward. But that doesn't mean that we need to kill the physics-based model which is already there. We have to go beyond that, and that is where data-driven AI comes into picture, where we introduce machine learning as well as neural network models being there and scaling across the system. And this needs time. This needs efficient data. This needs efficient time, because these models need to be trained over a period of time to get that. So that is where we call, how do we combine these two models and call it as an ensemble model. If I take a simple case of a cooling tower energy system, there could be multiple levels of modeling which is required. At an M1 level, you may have an air-water mixture property analysis which is there, a cooling tower first principle model at the next level, or a fan frequency model which to be done, or a fault detection or a diagnostic model, and finally a digital twin. And all these things needs to work hand in hand. It cannot work in silos, and that is where we need to have the right DataOps platform which we covered in the last slide. So that's now on top of that, when you apply industrial AI, you have the right capability in place. But the world has gone forward. So we have the data management solution, we have the industrial AI, but now we are more talking about agentic AI. And this is where I would like to introduce that we move from generative AI to a bounded agentic AI. And what is this all about? We have been talking about descriptive analytics over the last many years. And from there, we are going into predictive analytics, prescriptive analytics. And we have in the last 1.5, 2 years talking about generative AI capabilities as well. But with generative AI capabilities, you can summarize alarms, you can summarize your data, you can summarize your documents, you can also ensure that you get the right advice of how you run a turbine or an analyzer or multiple other assets. But is it really foolproof? Like an operator who has been there in the system for last 30, 40 years? That's a question where bounded agentic AI is there. And that's where the importance of human in the loop also comes into picture. It's not just about controlling agents, it is bringing accuracy through agents over a period of time, and that also through human-based, closed-loop analysis through that. That is where I would like to introduce the next solution, which is there, that is the Genix Copilot, which can talk about not operational data or instrumentation data or domain expertise or analytical AI or different tools and workflows, but it can bring all these together, generate a contextual intelligence environment, and that can help in generating explanation. The same thing what we use in many of the chat GPTs and all, explaining the things and helping us to understand the language which we can understand. But then in a manufacturing area, we can't stop at that place. From that, we need to also prioritize. What is the action? When an asset is down or when an analyzer is down, what is the action which I need to take? So if you go through a service manual, you will get 10 steps. But from that 10 steps, you need to prioritize which action to be taken first. That's where prioritization comes. Third, guidance. How does the agentic AI or the bounded agentic AI can guide you into a right action? And fourth, recommendations based on that. And also ensure that workflow support can be available across the different MCPs which has been deployed. This can generate a lot of confidence, not just in the shop floor operators, but also in the CXO or in the unit supervisors and other levels. So there is a complete shift from what we call as an information access to helping operators, helping the shop floor people to take decision in confidence using agentic AI. So this is where ABB comes into picture, and ABB has an expertise in this system in the last 140 years. It has been there in all the industrial revolution which has happened in the past, and this creates success, and it is trying to align with the different energy challenges which has been there, transforming the industries to what it is required today, embedding the sustainability as well as leading the whole industry in terms of technology. So with this, I would like to introduce two use cases in front of you. The first one is an asset performance solution. We saw one example in the previous presentation also, where how do we move from an asset signal to a real maintenance action? There is a 5 or a 6-step process which is required. So let's take a centrifugal pump, and then if there are some signal or a defect which you need to identify, the first step would be to detect what would it be. Then, as we said, to contextualize the data which is coming from different systems. Because you are not just talking about a centrifugal pump in its isolation. You are talking about what is its predecessor, what is its successor. And based on that, you are bringing context, contextual intelligence, and doing analysis on top of that. Then, based on this, you do an investigation about how you can take the right actions, which can generate recommendations. And if this recommendation needs an approval where human comes into a loop, you can have an approval step and then bring a verification step. And this is possible through the Ginix asset performance solution, which is out there. And this helps you to convert a complete, simple asset signal into real maintenance agentic role, which is there. The second use case which I want to introduce is about a product called Ginix Datalyzer, which actually helps to take all the measurement data or the compliance data which is coming from different analyzers which are deployed in the industries. Analyzers are those which measures the SOx and the NOx which is coming out of the industries. And it helps you to bring that data together to have a fleet management solution, emission visibility, as well as operational excellence in this. And this is where ABB builds different types of analyzers for its customers. Maybe it's continuous gas analyzers or water analyzers or analyzers for the oil and gas industries. So there are different analyzers, and we have almost 7 or 8 factories across the globe which actually builds this. Now, traditionally what used to happen is once these analyzers are built and it is deployed in the customer environment, service engineers used to go to these places to see if there is any maintenance issue which needs to be addressed. And based on that, they will try to come up with some solution. They try to contact the service engineers which are sitting in the ABB office in a far-flung area and try to see what can be the solution to be done. But now things are changing from here. Now you have an automated fleet management solution which is able to bring all these analyzer data into a central place which is sitting in a cloud instance. And from there, you are able to check the process conditions. You can review the analyzer's health and calibrate those analyzers to check if there is any anomaly which is there. As we said, there are multiple AI, ML, machine learning models which is running behind the scenes, which can bring this industrial knowledge out. You can use the Datalyzer Copilot, which can help you to summarize the likely causes and the recommended actions which are possible over here. And finally, it can create an approved services or a corrective workflow. Completely integrated, completely end-to-end. That is where we are going from an automation and to an autonomous place. So this is where the interaction is not just about technology advancement, But the way in which services are done in ABB is also changing drastically. Customer need not now just go and call up a service engineer. They can open a mobile app, scan the QR code which is there on their device, and as soon as they scan it and don't press on a button, that comes into the service engineer who is sitting in the ABB office. They will be able to analyze that data, link it with those different service manuals out there, and also see the last 24 hours or 48 hours or 3 months of data, bring both these things into context and generate the right answer for the customer and send it to the customer to take this action. So that is the power of agentic AI, which is coming in these days. So to conclude, we are talking about scaling industrial AI to autonomous operations. And this is the 6 steps which we talked about: to connect, to contextualize the data, then go into prediction, generate assistance, based on that assistance act, and finally go into an autonomous things. From data to insights and from insight to action, as well as helping autonomous operations. So we don't need to scale by projects anymore. We need to scale by patterns. If you start scaling by projects, you will not be able to scale more than 10 pilots. But if you scale by patterns, you will be able to scale across the industries and generate reusable components which can be used for your next projects as well. And this is possible, and this helps in ensuring that the customer really gets value in terms of the downtime which they are facing, or the data ingestion or the investigation time period, or the energy saved, as well as the service productivity. And therefore, 3 takeaways for any of the manufacturing leaders which is there out here. Try to build your projects on a proper industrial DataOps foundation. Ensure that you have a bounded agentic AI, and this will help you to reuse your components and scale across different patterns. Thank you so much.